Okay, well, I started by graphing the actual function that was given up here. So this is the line 1/3 x plus 5. But that's from -6 only to -3. Okay, so that, believe it or not, is this. And I started by going up 1, 2, 3, 4, 5, and then I did a slope of 3. So I did up 1/3, but I wanted to be going in the negative direction, so I went backwards. Okay, so I went down 1/3, down 1/3, and so on. Okay, so that's this little section right here. Then I have -x plus 1, so there's my y-intercept. But I have a negative slope of 1, so I went up 1 to the left 1, up 1 to the left 1. And that's from -3 to 3, which is this portion right here. And then I just have the horizontal line y equals -2, which is down here. Okay, now with right Riemann sums, I'm going to show you from a picture, and I'm going to show you from the chart. So what I did was I made a list. So I also created a chart using an x value of -6. So here's -6, and I went up 3. So there's its y value. Then I went to -3, and I went up to its y value, which is 4. 0's y value is 1, and so on and so on. And I did it using these intervals because it says a right Riemann sum with 4 subintervals. Okay? And so what I mean by that is we're going to group this chart into 4 subintervals. So here's going to be my first one, second, third, fourth. Okay, so if you prefer a chart, then we'll do it using the chart method, which is, I think, the easier way to do this. Okay? All right, so then to find the right Riemann sum, you should see that the width of each of these intervals is a distance of 3. Okay, so the width of each rectangle is going to be 3. And then let's look at the height. So we're using right Riemann sum. So for this first subinterval here, -3 is on the right, and I'm going to its height of 4. Okay, and then when I go to the next interval from -3 to 0, 0 is on the right. I'm going to its height, which is 1. Then the next interval I will be 0 and 3. 3 is on the right. I'm going to its height, which is -2. And then the last one between 3 and 6. 6 is the number on the right. Its height is -2. Okay, so let me write all those numbers down. So the first one, again, will have a height of 4. The second interval will have a height of 1. The third interval will have a height of -2. And the last interval will also have a height of -2. Okay, so then all we have to do at this point is just add those numbers up, which is going to give me 1, and multiply, and there's your answer. Alrighty, so number 2 wants a left Riemann sum. So we want 4 subintervals again. So here, same as the last one. Okay, but we want a left Riemann sum. So this time we are going to be looking at this interval and looking at the number on the left and going to its height. Okay, then looking at this interval, look at the number on the left, go to its height. Number on the left, which is 0, its height. And then the last one is 3 to 6, number on the left, its height. Okay, just like the last one, the width of each rectangle is going to be 3. So I'm going to do 3. And then my heights would be 3, 4, 1, and -2. So that's going to be 3 times 6, and that will be 18. Okay, so let's look at part A. Same graph again. Now, we want the integral from 0 to 0. Remember, if the bounds are the same, this is the area under the curve. From 0 to 0, we haven't even gone anywhere. So we start here and we don't go anywhere. There's no area then. Okay, so when the bounds are the same, regardless of what the numbers are, like here it's from 0 to 0, but if it was from 2 to 2, doesn't matter. Your integral or your area under the curve is always going to be 0. All right, so now they're asking from 0 to 2. So let me change my color here just so you can see. So this is asking for the area under the curve from 0 to 2. I'm going to shade that for you. And if you look from 0 to 2, it would be that area there and that area there. Okay. Correct me if I'm wrong, but aren't those the same size triangles, but one's above the curve, the x-axis rather, and the other one is below? See, this one has a height of 1 and a base of 1. This one also has a height of 1 in the negative direction, but still a height of 1 and a base of 1. So these guys are the same exact size, but this will have a positive area because it's above the x-axis, and this is going to have a negative area because it's below the x-axis. Okay, so guess what? Answer is still 0. Okay, all right. Now let's look from 0 to 3. That's what part C is saying. So everything that I have over there shaded in red, except I am going to go to x equals 3, 1, 2, 3. So that's going to be actually all of this space. Do you guys see that? Okay, now you can do what I did before. So from 0 to 1 and 1 to 2, that would cancel out, right? Those would be 0. And then all I'm going to do is take the area from 2 to 3, which is a trapezoid. Okay, so let me write that in another way. So I'm going to put 3 down here. Okay. I'm going to start by breaking it up. So I'm going to have the integral from 0 to 2, and then I'm going to tack onto it the integral from 2 to 3. Well, I know that the integral from 0 to 2 is 0. That's part B's the answer, right? Okay, now if we look at the space from 2 to 3, that's a trapezoid. So I'm going to do 1/2 the height, and then I'm going to add the 2 bases. So let's talk about that for a second. Your height is actually this distance right here, which is 1. And your bases have to be parallel. So here's one base, and there's the other base. Okay, so the height will be 1. One of the other bases will be 1, and the other one will be 2. So we are going to have essentially 1/2 of 3. And you can just write that as 3/2. You don't need to do anything else beyond that. However, one thing I need to just make sure that I'm careful of is look at where this space is. It's underneath the x-axis. So please make sure, and I'm going to put it in red so you see that, that will be a negative 3/2. So your answer for C is negative 3/2, final answer. All right, so for part D, they want the area from 0 to 6. So I'm going to break that up. I already know the area from 0 to 3. That's my answer from part C, right? And then what I'm going to do is I'm going to add to that the area from 3 to 6. All right, so from 0 to 3, we know that that's negative 3/2. Okay, then what I'm going to add to it is the area from 3 to 6. Okay, so 3 to 6 would be this space right here, which is that rectangle. But understand, it's below the x-axis, so it is going to be negative. So I'm going to put that negative there. And my base is 3, and my height is 2. Okay, so that would be negative 6, right? So that's negative 3/2 minus, and I'm going to make that 12/2 because that's the same thing as negative 6, right? So that's going to be negative 15 halves. There's your answer for part D. All right, now E wants you to go from 0 to negative 3. Remember, when we do this, we can't have the higher bound be the lower number of these two. So I'm going to flip these guys around, and remember, I need to negate. So I'm going to write it as this: the negative of negative 3 to 0 of f of x dx. Okay, so they just want the area under the curve from negative 3 to 0, but I'm going to negate that answer. Okay, all right, so negative 3 to 0 would be, that space right there. Okay, and if you look at that, that is a trapezoid, and it's above the x-axis, so our answer is going to be positive. However, the negative in front of the integral will negate that. Okay, so I'm going to bring this negative down. So that's going to be negative. And now let's take the area of the trapezoid, 1/2. Okay, now your height is right here. Oops, sorry, your height is right here. Okay, and then here's one base, and there's the other right there. Okay, all right, so the height is 2. And then your base 1, doesn't really matter what order you go in, but one of them is 3, and the other one is 1. All right, so this is going to give me a -1, or just a negative. And then inside the parentheses there, I have 4. Okay, so your answer should be -4. Okay, and I stand corrected. I made a small mistake here. -3 is out here, so that height, let me just kind of shade that space for you. Okay, so this should not be a 3, this should be a 4, which would make this a 5. Okay. And in addition to that, then that would make this height a 3. let's just get rid of that altogether. Sorry about that, guys. So that's going to be -3/2 times 5. There we go. And that's going to be -15/2. Final answer, I swear. Okay? All right, so looking at part F, the first thing that I notice here is my bounds aren't in the right spot. So I need to have my lower number down here and my higher number, 0, up top. So you know that that means that we need to negate and flip the bounds, right? So I'm going to negate, and then I'm going to flip the bounds. So I'm going to put -6 down here and 0 here, okay? F of x dx. So I know that I am going to find the area under the curve from -6. So I've got right here, this is 1, 2, 3, 4, 5, 6. So basically, I just need to find the area of this space in here, because I already have the area from 0 to -3 right here. Okay, so I'm going to split this up into 2 integrals, like I did in part D. And I am going to, we're going to have the negative, we're going to keep that. And I am going to go from -3 to 0, plus, and then the integral from -6 to -3. Okay, well, I know the first integral from -3 to 0 is -15/2. Okay, but let's just talk about that for a second. This is negative because these bounds were wrong. However, if I'm going from -3 to 0, that's really just this space shaded in red, and that is above the x-axis. So the value that I should put here is a positive 15/2. Okay, so this is 15/2. However, that negative there is going to make it negative. Okay, all right, so I'm going to have -15/2 over here on the left side, then plus, and now I'm going to find the area from, and let me do this in a different color so that we can see it. Okay, so I'm going to take the area of this space right here, and that's a trapezoid. All right, so we're going to do 1/2, the height, which is 3, and then we're going to multiply by the 2 bases, add it up, which would be 3 plus 4. All right, so you know what I'm going to do? Let me back up for a second here. Okay, I think the better way to go about this is let me keep that negative on the outside of parentheses. That's really what I should do, okay? Because if you look at the step above, I'm negating this entire integral. So let's just keep it like that. So I'm just going to go like this, if that works for you. I think that's probably the more correct way to do it. So let's keep this negative, and then I'm going to have 15/2 plus, and then here I'm going to have, let's look here. So I'm going to have 7 times 3, which is 21, over 2. Okay, I like that way better. So 21 over 2. We're going to add those up, and that's going to be negative, and then when we add those guys, that's 36 over 2. So your final answer is negative 18. Number 4, so they asked you to graph it, so there's your graph, piecewise function, and I just went ahead and I made a chart here, and we wanted 4 subintervals, so I just sectioned those guys off, and we want a right Riemann sum. Now you should see that the width of every single one of these is 3, so I'm going to go ahead and just write 3 times, and then I'm going to find the right hand height of each interval. So here's my first interval. This number's on the right, its height is 0. This is my second interval. 0 is on the right, that's its height. Third interval, 3 is on the right, that's its height. Last interval, 3 to 6, 6 is the one on the right, and that's its height. Okay, so I'm just going to add those guys up. So I'm going to add 0, 3, 0, and negative 3. So basically, that is 3 times nothing, which would be nothing. Okay, that doesn't happen often, but it's correct. Trapezoidal approximation for equal subintervals. You can see that I put my little subinterval brackets up there. Okay, and look at the width of each of these subintervals. They're all a width of 3. So on the trapezoid, that's actually going to be the height. Right, so remember we have 1/2 height, and then it's base 1 plus base 2. And your height is actually the distance between each of these numbers in your interval. So there's a distance of 3 here, a distance of 3 here, 3, 3. So that's what your height's going to be. Your bases are your y values. So these are the 2 bases of the first interval. 0 to 3 are the next 2, and so on and so on. Okay? All right, so let's get started. So I have 1/2. The height, again, is 3. And then I am going to have, for the first one, 6 plus 0 would be your bases. The second one, also 1/2 3. And we're going to have 0 plus 3 this time. The third one, again, 1/2 3. And this time we'll have 3 plus 0. And then the last one, 1/2 3. And we are going to have 0 plus negative 3. Negative 3. There we go. All right. So we're going to have 6 times 3, which is 18, and half of that is 9. This would be 9/2. This one would be also 9/2. And this one is going to be negative 9/2. All right, well, if I am going to add all these up, right, because that's what a trapezoidal estimate would be, these two will cancel out. So really what I'm doing then is I'm going to turn that 9 into 18/2 plus the 9/2, the second one down there, and when I add that, I get 27 over 2. So let's look at this one. They want for part D, -3 to 6. So again, that's that half circle. And now they want this whole triangle. It's really similar to part C, really, except that the triangle is just a tad bit bigger. I'm going to break that up again. So I'm going to go from -3 to 3, which I already have the answer. Remember, that's from part B. And then I'm going to go from 3 to 6. All right, so -3 to 3 we know is 9 pi over 2. And I'm going to make this minus because that triangle is underneath the x-axis, and I've got 1/2 of 3 times 3. That leaves me with 9 pi over 2 minus 9 over 2. And we can just leave it like that. All right, now part E, let's just be careful here because these bounds need to get flipped. And remember, when we flip bounds, we need to negate the integral. So that's going to be negative, the integral from -6 to -3 of f of x dx. So we're looking at the area under the curve from -6, which is right here, all the way to -3, which is right here. So that's this triangle right there, okay? But our answer is going to get negated because we had to flip the bounds. So that's what this negative means. And then I'm going to do 1/2 the base, which is a distance of 3, and a height, which is a distance of 6. 18 half of that, so that would be -9 as your answer. And last one, ooh, I love this one, 0, because the bounds are the same. All right, so for 8, we want to write Riemann's sum, 6 subintervals. You can see that I bracketed off all the intervals, and each interval has a width of 2. And then I'm just going to use the right side of each interval, its y value. So we would have -1, then +1. Let's make that look like a -1. Then I've got 2, then I've got 3, then I've got 5, and then I've got 3. Okay. All right, so I'm going to add all of those up. Well, -1 and +1, that's 0. So 5, 10, we've got 13, right? And that ends up being 26. All right, same thing on the left side, except I'm going to use the left y values. That's going to be -3 plus -1 plus 1 plus 2 plus 3 and plus 5. And we're going to get 2 times, and let's see what we have here. We should have 7, which ends up giving me 14. Number 10 asks you to do midpoint, 3 subintervals. I bracketed those guys off, and then I also circled the middle of each interval. Okay, now each interval should be a distance of 4 wide. And then the middle of the first interval has a height of -1. The middle of the second interval has a height of 2. And the middle of the third interval has a height of 5. So we've got 4, and what do we have here? 7 minus 1, so that's going to be 6, right? Final answer, 24. Okay, so for number 11A, just remember what this actually means. They gave you a formula to use, so what they want you to do is replace your x value here with 0, which means here I'm also going to replace that with 0. So that's what I have right here. So what this all means is look at the picture, and I'm basically going to take the area under the curve from -2 up to 0. Okay, so from -2 up to 0, oops, here's -2 to 0. We're looking for the area of that trapezoid. All right, so that's going to be, and it's above the x-axis, so it's positive, 1/2. Now, be careful again, the height is actually this way, and the bases run vertical because they're parallel to each other. Okay, So just try to remember that. So our height is 2. And the first base, well, it doesn't really matter what order you put them in. One of them's 1 and the other one's 2. Okay, and half of 2 is just 1, so our final answer is going to be 3. All right, now part B wants f of 2. Remember again, f of 2 means we're going to put 2 here and we're going to put 2 here. So that's how I got this integral to go from -2 to 2. If we want the integral from -2 to 2, it's basically what I already highlighted in red, plus, here we go, that piece right there. Okay, so those two trapezoids put together, right? All right, I'm going to break this up, and I'm going to go from -2 to 0. And then I'm going to go from 0 to 2. Well, I already know what -2 to 0 is. That's the answer from part A, so this is 3. And this one, I'm going to do 1/2, the height, which is 2, and the bases, which are 2 and 3. And that's going to be 3 plus 5. Final answer is 8. All right, let's look at part C. Same deal again. You've got f of 4, so I plugged in 4 for the top bound. I would split this up again, and I am going to go from -2 to 2 because that's my answer to part B. And then I'm going to add to it from 2 to 4. Let me get my little pointer going. So again, this is these two red areas right here, and that we already have is 8, okay? But in addition, I'm going from 2 to 4. Now be careful about 2 to 4. Let me outline it in green so you can see that. 2 to 4 is all of this space, okay? Now look at that. You actually have, I'm going to split it. You've got this quarter circle right here, plus you've got that rectangle right there. So you're going to have to do both of them. All right, so the -2 to 2, again, we know that that's 8. And then we're going to add to it. Let's do the rectangle first, okay? So we know that the rectangle is 2 times 3, right? So 2 times 3 plus, and then a quarter circle, 1/4 pi, and then the radius is 2, and we're going to square that. All right, so that gives us 8 plus 6 plus pi. So our final answer should be 14 plus pi. All right, D, 0. Okay, let's look at the distance between, or the area under the curve between -2 and -4. So -2 and -4 is this piece plus this piece right here. Now look at those very carefully. Well, not too carefully, because honestly I think that's pretty obvious. Same size triangles, but one's positive and one is negative. Okay, so that's going to end up being 0. Now let me just also talk about something that I really should have said first, but I have an issue with this because -2 is larger than -4. So shouldn't I flip and negate this? But listen, yes, I am supposed to do that, by the way, but because the area of both of these triangles is same, except one's positive, one's negative, it doesn't matter. You can't negate 0. So in this specific instance, it kind of overrides it. So the answer is 0 for that one. Okay, so now let's look at here. Do I have an issue with the bounds? Yes, I do. I'm going to rewrite this then as negative, and then I'm going to flip those bounds, -6 to -2 rather. Okay, and then we've got f of t dt. So I'm going to take whatever answer I get, and I'm going to negate that answer. right, I'm going to put that work down here. So I'm going to split this up, and I'm going to go from -6 to -4, and then with that, I'm going to add -2 to 2. I'm sorry, -4 to -2, okay, which is my answer from part E. So I already know that that's 0. All right, now let's look at -6 to -4. Let me outline that. So -6, so that's 4, 5, 6, -6 to -4. That would be that trapezoid, right? Okay, and notice though that that trapezoid is below the x-axis, so I am going to negate that because it's below the x-axis. -1/2, the height is 2. The one base is 1, and the other one is 3, right? All right, and when we work that all out, that is going to be -4. Technically, again, +0, but, you know, there we go. Okay, last question. Part A, we are going to find the area under the curve from -4 all the way up to +2. Look at what I'm doing. That's both of those figures. So we've got a triangle and we have a half circle, but notice that they are both under the x-axis, so I'm going to negate those areas. So for the triangle, I'm going to do -1/2, the base, which is 1, and the height, which is 2, plus -1/2 pi r, which is 2 squared. And that ends up giving me -1 minus pi. You can leave your answer just like that. Okay. Let's look at part B. So part B goes from 0 to 4. Let me put that in a different color. So 0 to 4 would mean this piece right here, that's 0 to 2, and then this piece right there, those two added up. So we have a quarter circle, but notice that it's underneath the x-axis, so we're going to negate that. Okay, let me just kind of go like this. So I'm going to negate that 1/4 pi, and then the radius is 2. And then the area of that triangle, that's above the x-axis, so I'm good to go there. 1/2, 2 times 2. I will get -pi with regards to the half circle. That's pi. And here I'm going to get +2. And that's the answer to that. All right, number 6, I'm going to put it down here. Now they want me to go from -4 to +6, which is essentially the entire picture that we have here. So that's asking for all of this plus all of that. Okay? All right. I'm going to split this up and as best as I can. So let's see. I'm going to start with integrating from -2 to +4. Sorry, I said that wrong. -4 to +2. I switched my numbers. Okay, and that basically is all of this and is also the answer from part A. Okay, so we know that that is -1 minus pi. And then I'm going to integrate and look at the area under the curve from 2 to 6. And that's the green triangle above the x-axis that I have. So 1/2, and the base is 1, 2, 3, 4, and the height is 2. So I've got -1 minus pi plus 4. And that ends up being 3 minus pi. There's your answer.